All right, so today we're doing something a little different. We're going to go on a mission, you and I. We are going to crack open a real GCSE physics exam question and see exactly what it takes to get every single mark. You ready? Let's get into it.
So check this out. This single question, it's worth a whopping 11 marks. I mean, that's enough to potentially bump you up a whole grade. It covers sound, a bit of tricky math, and even electromagnetism. So our job is to break it down piece by piece and claim every last one of those points.
So here's how we're going to break this down. First, we'll get a feel for the whole question. Then we'll jump into the first part, which is all about sound, animals, and time. After that, we'll tackle the big one, the 4-mark calculation. Then we'll get into the physics of a moving coil microphone. And finally, we'll pack it all up into a neat little toolkit you can use in your exams.
Okay, let's get started. Time to meet our 11-mark beast of a question. Now, this is a classic for a reason. It's designed to test a whole range of your physics skills, from reading tables and graphs to nailing your calculations and, writing out a really clear explanation. First up, we're going to tackle the first couple of parts. These are all about sound frequencies and making sure you know your scientific prefixes. Now, they might look easy, but trust me, these are exactly the kind of questions where it's super easy to drop a mark if you're not paying attention.
So, question 09.1 asks, which one of the animals from Table 3 would not be able to hear ultrasound? Simple question, right? So, to get this right, you got to know one key thing. What even is ultrasound? Once you know that, it's just a matter of checking the numbers in this table.
And that's the secret right there. Ultrasound is basically any sound with a frequency that's higher than 20 kilohertz, which is pretty much where human hearing tops out. So with that definition in our pocket, we just need to find the one animal in the table whose hearing range stops before it hits that 20 kilohertz mark.
And boom, there it is. You just scan down the table and you see it, the chicken. Its hearing stops at just 2 kilohertz. All the other animals on that list can hear way above 20 kilohertz. So the mark scheme answer is chicken. First mark in the bag, easy.
All right, next up, question 9.2. This one's a straight-up test of whether you know your SI prefixes and standard form. The mission, change 2 microseconds into seconds. The real question is, what on earth does that little prefix micro even mean?
Knowing your prefixes is a legit superpower in physics. Micro just means 1/1,000,000th, and in standard form, that's 10 to the power of -6. So our answer has to be C, 2 times 10 to the -6 seconds. Boom, another mark down. See? Let's keep this ball rolling.
Okay, deep breath. Here comes the main event, the 4-mark calculation. This is where showing your work step by step and paying attention to all the tiny details will make all the difference. We're asked to find the depth of a crack in a block of aluminum. Let's do this.
So let's play detective for a second. All the clues we need are right here on the screen. The question straight up tells us the speed of the ultrasound is 6,300 meters per second. And if you look closely at that oscilloscope screen, it says each little horizontal square, each division, is 2 microseconds.
Look, to get all 4 marks, you can't just jump to the answer. You've got to show your thinking, step by step. So here's our 4-step plan. First, find the time delay from the screen. Second, write down the formula. Third, plug in the numbers and find the total distance. And fourth, and this one's crucial, we do one last little calculation to find the actual depth. First things first, let's figure out the time. If you look at the screen, the gap between the 2 pulses is exactly 6 squares, or 6 divisions wide, and we know each one is 2 microseconds. So that's just 6 times 2, which, is 12 microseconds. That's our first mark, right there.
Okay, step 2. This one is so easy to forget, but it's often a free mark. Just write down the formula you're going to use. In this case, it's the classic distance equals speed times time. Don't skip this.
All right, step 3. Now we plug in the numbers. But hang on, here's a really important bit. We have to convert those 12 microseconds into regular seconds before we do the math. That's 0.000012 seconds. So we multiply 6,300 by 0.000012, and that gives us 0.0756 meters.
But wait, are we done? Is that it? Uh-oh. This is the classic trap that catches so many people out. Think about it. That time we measured, that's the time it took for the sound to go down to the crack and then echo all the way back. The question is asking for the depth.
So for that next crucial mark, you have to remember to cut that distance in half. So 0.0756 divided by 2 gives us 0.0378 meters.
And for the final point, you just have to check the question. It asks for the answer to two significant figures, so we round our number to 0.038 meters. And that is how you bag all 4 marks.
Okay, we're on the home stretch now. Let's tackle the last part of this question. We're looking at a diagram of a moving coil microphone. And this section is all about testing whether you can explain how a microphone turns sound energy into an electrical signal.
So first, they hit you with a nice, simple 1 marker. What's the function of a microphone? Well, the mark scheme is just looking for something clear and simple. It's a gadget that takes the pressure changes in sound waves and turns them into a changing electrical current or signal.
And now for the grand finale, another 4-pointer for explaining how this thing actually works. To get the full credit here, you've got to describe the chain of events, from the sound wave hitting it to the electrical signal coming out, mentioning the key parts from the diagram.
You basically need to tell a 4-part story to get all the marks. Here it is. 1. Sound waves come in and hit the diaphragm, making it vibrate. Easy. 2. There's a coil of wire stuck to the diaphragm, so when the diaphragm vibrates, the coil vibrates too. 3. That vibrating coil is moving back and forth through the magnetic field from the permanent magnet. And 4, this is the physics magic, anytime a wire cuts through magnetic field lines, a voltage is induced across it. That voltage is the electrical signal. It's a principle called electromagnetic induction.
And just like that, we've done it. We have picked apart that entire 11-mark question. But the real goal here is to learn the strategy, right? So let's wrap this all up into your own personal toolkit for acing these kinds of questions.
Okay, here it is. Number 1, always show you're working. It can save you. Number 2, read every single word. Remember that depth versus distance trick? That was worth a whole mark. 3, get comfortable with your units and prefixes. 4, always double-check if you need to round your final answer. And finally, for those long explain questions, just tell the story, step by step, using the right science words. Okay, so I want to leave you with one final thought. We just saw how moving a coil near a magnet can create a voltage. That principle, electromagnetism induction, is literally one of the most important ideas in all of physics. It's everywhere. So can you think of other places it's used? What about the giant generators that create our electricity? Or even the pickups on an electric guitar? It's the exact same physics at work. Pretty cool, right?